What's up, guys? Um, Today we're gonna do homework number 134, which is question is find out the force on 1.0 microcoulomb in this diagram. We are looking for the magnitude and the direction. Here's the diagram. So I'm going to assign this as Q1. This is a Q2, and this is a Q3. We know the known situation in here, condition is Q1 equal to 1.0 nanocoulomb, and convert into coulomb is 1.0 times to the -9 coulomb. Q2 in here is 2.0 nanocoulomb, which is 9.0 times to -9 coulomb. Q3 is -2.0 nanocoulomb, so as just different sign as this Q2. We are also known that we are gonna use the equation, which is F equal to K times Q1 Q2 times R squared. So K is also a known condition, which is K equal to 9.0 times 10 to the 9 Newton meter square and per coulomb square. How do we solve this problem? We need to draw the free body diagram on Q1, charge Q1. So how do we draw it? I'm here gonna draw this stuff. So I'd like to use a different color like purple to represent two same charge. A red one as a different charge. So they are in triangular status, and then we know the question gives us this angle is 60. The three side line is 1.0 centimeter. Now same as this is also 60 degrees. Right now, to do this problem, you have to know the force of a supercondition. The force of a superstation. So first you got to draw the repelling vector in Q1. So it will be like this. This is Q1, it's Q2, it's Q3. We know Q1 and Q3 are different charge, so it turns out they attract each other. So show it like that. Yeah, and we know from 6a, so how to draw the vector is head to the tail, so just like that. And this is F9. This is F2 on 1. This is F3 on 1. Now we need to solve F9. We need to know what's the component of F9. And here F9 represent F2 on 1x component plus F3 on 1x component. That represent is the sum of x component is F9, because F9 doesn't have any component on y component. So to solve this problem, we just need to use this equation to find out what is the x component of f2 onto the 1, and same as s component of f3 onto 1. So how do we solve the problem? We use this equation, f equal to k times q1 q2 times r squared times fx 2 to the 1 is cosine 60. Why is it cosine 60? Because we know in here is 60 degrees, and then I'm gonna draw this x component and y component for the f force 2 onto 1. So just like this. So this is a y component of fy 2 to the 1, and this is f 2 to the 1 x. Because this vector is parallel to this line, so it turns out this angle is also 60. So same as this one. So I'm going to draw this triangle, which is a vector, x component and a y component. And this is a y component for f 3 to 1 y, and this is f 3 to 1 x. So same as here, this vector is actually parallel to this one. So it turns out this angle is the same as this angle. So it's 60. And we know they both have same volume of charge, but just in different sign. So it turns out we are looking for the only one calculation will be solve all problem. So in here, k is 9.0 times to 10 to the 9 Newton meter square per coulomb, time q1 is 1.0 times to 10 to the negative 9 coulomb, time it's here, time 2.0 times 10 to the negative 9 coulomb, and r squared is 1.0 times 10 to the negative 2 meter, because it's centimeter, so we're gonna convert to the meter, and this giving us 8.99 times 10 to the negative 5 Newton I component. And we know in here I should say times cosine 60. So we have this result. So we know f2 to the 1x is 8.99 times 10 to the negative 5 Newton I component. And we also know f2 is, q2 equal to q3 in absolute volume. I'm sorry about that, Papa. So it turns out f3 to the 1x is also 9.99 times 10 to the negative 5 Newton per Newton x component. So f net will be the sum of f3 1x plus f2 to the 1x equal to 1.798 times 10 to the negative 4 Newton, and direct to right. And thank you for watching. Thank you.